All right, let's do this. Okay, this is me. Nobody's going to do the introduction for me, so I'm going to introduce myself. And I'm X-Wings. I'm from JD.com, online e-commerce company. The only thing with e-commerce in China is you always buy things today and it arrived yesterday. So that is the speed that we're looking at. I mean, this country really get me broke. Oh, Max sent me a message and asked me, all good? So, okay, let's continue. Of course, I'm part of, I think, I'm still part of Hang the Box if they didn't remove me from the name list. Okay. And I created a Qiling framework last year and we released it in, we sort of demo it and to show it in a DEF CON last year. You know, last year is like the ancient time when we still have a proper conference that everybody can shake everybody's hand and see everybody. Not like now, I'm looking at the cam and oh, Anthony's there. Not looking at the cam and just like talking to myself. You know, if everybody agrees that, you know, send me a agree message to tell us to at least to tell me that you guys love proper conference rather than this sitting at home and looking at this monitor and it's okay. Yeah, it's shit. Damn it. Okay, so we did an official release for Qiling framework last year. When was that? In Russia around November. So and I'm also running this little project called Batch Maker. So again, during proper conference, we designed some batch for Hack in the Box, like you know, Amsterdam, Singapore, HITB, Beijing. Okay, so this more or less me and myself. Okay, and these are some of the guys that actually helped me to design not help me to design. I designed Qiling framework, and they helped me to code it on you know how the syscall and all the details and the small little stuff and how I want Qiling framework to be. And of course, the mother of all motherfucker, Queen. You know, you guys know Queen. Quinn is the one that created a Unicorn Engine, Keystone, and Capstone. So he's our advisor. He's a code freak. He controls all the space, all the where should we put a comma, what are the variable name to use in our code base. So yeah, that's Quinn. Okay. So this is the introduction of our team. Okay. Before we start, please go to you know, look at the URL up there, github.com, Qiling framework and Qiling. Give us a star, you know, the stars thingy. We are like open source project, and then we are fit on star. You know what I mean? We are just there to Hey, hi Anthony, you turn on your cam. And what is that mask for? Damn it, throw it away. I thought you're not supposed to wear mask in Hong Kong. Police will catch you. Ah, now you want to show dog. Damn it, where's my dog? มีอะไร? Okay, so give us a star if you haven't. Okay, that is pretty much a sign of a sign of appreciation on the project. I mean, whether you use it or not is another story. So yeah, that's the star for. Okay, so I'm gonna do a little bit of introduction. I'm not too sure there are how many guys today have seen our project. So I'm gonna do a little bit introduction, and I'm gonna discuss a bit on how and why we want to start this project. I want to start this project. So this is IoT. And then after I moved to China, after I started my career in China, I keep on buying stuff. Whether I use it or not is another story. But IoT is fun. You can look at how those idiots design all kind of weird project, just like you know, IoT blender. I'm not too sure what's that for. Watch, TV, maybe. Power socket. God damn it! Why do you need a power IoT based power socket? And then I have these security cameras. And it's a fun place to buy IoT stuff. So that is IoT. And then we talked about a bit on the traditional IoT hacking. So traditional IoT hacking is pretty much, IoT hacking, it's not traditional at all. That is what I put it, okay? And traditional IoT hacking simply means we are looking at web-based hacking. They try to look for a bug inside the CGI variables and try to do a command injection, try to do some authentication bypass. That is pretty much, to me, it's traditional IoT hacking. So it's not really new stuff, but people trying to bypass, securities and try to get access to IoT. That is and that is how people do it. Of course, and then it evolved, become firmware hacking. So people started to get firmware and then try to extract the firmware with all the complicated method. Of course, nowadays, when we try to extract the firmware, we can use binwalk. But the days before binwalk, it's a pain, for you to extract firmware, for you to try to figure out how does the firmware looks like, what kind of file system are you looking at, especially when GFFS 2 just came out. It's not easy for you to look at all the different firmwares. And the hardware hacking group. So you have all these hardware hackers try to play around with the thing, and they don't really cross over to each other during those days. So the software guy don't really touch the hardware stuff. The hardware guys don't really do the software stuff. So it become a few different school of thought when it comes to IoT hacking. Of course, I'm always in the middle one, so that's the reason why I have all kind of weird tools at the back of me. This is my house and my workshop. So that's the three school of thought previously. Okay, so and when we move on, okay, the only thing, if you ask me personally, I don't know about you guys, all right. So if you ask me personally, why do I like hardware hacking? You're gonna buy a lot of stuff for hardware hacking, and you're gonna enjoy buying stuff, So especially in this country with all this kind of weird e-commerce going on in this country, the delivery speed, the choices of the product, and the price is totally amazing. You can basically buy whatever things you want, and the delivery speed is fast. You don't have to wait for like 2 weeks to get your stuff. Waiting for 3 days for your stuff to arrive in front of the doorstep, that is crazy enough. Okay, so there are a few important things that you need for IoT hardware hacking. The first thing first is you always need a hot air gun. Okay, I will not go into details of a soldering iron. Everybody will have a soldering iron. That is fine. But when it comes to a hot air gun, there are guys that they always buy the cheaper ones or the expensive one, and there is a different. Trust me, there's a different for a hot air gun. So I always want to tell my friends, when you pick a hot air gun, pick a proper electronic hot air guns. Hot air guns designed for electronic purposes. So the reason why is if you buy a cheaper one, or you buy those industrial hardware hot air gun that they use it for all the hardware projects. Okay, not electronics project. We are talking about those hardware projects. Those type of hot air gun, or the cheap hot air guns, the one on the right, the black color hot air gun, that is the one that will give you statics. It will break your board, it will break your chips, it will break whatever things that you try to blow from a hot air gun. So of course, any proper hot air gun will be things like designed for electronics. I'm not too sure you guys can see this hot air gun. Okay, so these are one of those proper hot air gun that you should be using. soldering paste takes long time to arrive. Where the hell are you from? Okay, and multimeter. So they are again, they are cheap multimeters. You know, they are expensive multimeters. Always go for expensive one. I'm not looking for fluke, but always try to get fluke. That is a proper multimeter. The only reason is those cheaper multimeter, you always tend to have all the different kind of settings. So you need to turn to the right option before you can do the right readings. That will cause you to have more troubles if you got no idea what you're doing, especially you are a beginner. So you need to get those proper multimeter to help you to do the voltage, because the category is lesser. You will not screw up and have the wrong reading, and you will not go into places, you know, to screw up your multimeter readings. So these are the few hardware parts before you try to do a hardware hacking, IoT hacking, or you know, firmware hacking. So I'm going to talk about a bit on the experience. Okay, my personal experience, how I screwed up my cam, you know. So I'm from Malaysia. So before I come to China and work, I love to buy stuff from China and ship it back to Malaysia. So we have this this kind of forwarder thingy, so you can buy stuff, send it to the forwarder, and the forwarder help you to send it to Malaysia. So I was eyeing at this Xiaomi camera, and then this camera talks a lot, really. They started to once I try to install and initiate the cam, it says you cannot run this camera outside China. So you know, it was like a goddamn thing. I check out. Of course, if you go to a China search engine, it will not tell you anything, because the search engine is not working at all. It's not a search engine; it's an advertisement platform. Okay. Hopefully, nobody from China. Anybody from China? No. Nobody answering. So is the Chinese government tapping my line right now? And we're using Zoom. Damn it. Okay. So so I couldn't find any answer, but but from Google there is some hint that I can go along. And so I try to look at the schematics. I try to look at the blog. There are some methods for me to downgrade this cam, but apparently it's not working due to the chipset and the specific model. I cannot downgrade to the specific version I want. And there are some guys managed to get the TTL UART, and I think I managed to get it during that time. So you can see the version that I have and the version that they have on the internet is similar, but the connection is totally different. So somehow I managed to get get the ground. I managed to get the RX and TX, of course, by using a multimeter. So after I get all these things, then I can try to change the network settings. The only reason I wanted to get a shell is I can set up that's what I was thinking. I can change the user interface, and I can try to upload a bit more program. Example, I can upload a MIPS-based telnet, a MIP-based FTP, or the RTSP server. But the only things that get me not working, it's I try to upload telnet, I try to upload RTSP, I try to upload FTP. The space inside the partition that holds /bin or USR /bin, it's not that big. So during that time, I decided maybe I can resize some other not really useful partition and try to rewrite the firmware in and try to relay everything. So that is what I was doing back then after I got a shell for this cam. And after I moved the field of the binary to the a new folder, and the only thing I realized is I've forgotten to mount, and the kernels need to load that field binary before it can boot up, and I screwed up everything. So remember, I cannot reset to back factory default. I cannot downgrade, I cannot upgrade. I can reset to factory default, but apparently the binary is not there. So the factory default is not the real factory default. The factory default is just about clearing out the NVRAM. And so the issue I'm facing right now is I have a kernel panic and I cannot boot up the device. Okay, I can see from the USB TTL, the entire console is not. I only managed to get the console with a kernel panic. So one thing about hacking IoT, one thing about hacking all this hardware is please, you know, check your data sheet. That is the lesson I learned during those days when I started to hack all this IoT stuff. So by reading the data sheet, most probably I know that there is a chip. Okay, these are serial flash chips that's where they store all the images. So the only thing I know is I might be able to get, because I know the from the picture I know that it's HiSilicon. Okay, is Huawei's company, HiSilicon 3518 chip, and then most of the Xiaomi cam is based on this chip. So technically, I should be able to use one of these firmware to flash into the chip. So that's what I did. And then I dig back by my older version or some of the message from the internet. I know this is how the partitions looks like. So if you look at the middle of the message, these are the things that they are looking at. And then I solder back. I did a soldering. During that time, I don't have a hot air gun. Most probably, I still got no idea what is a hot air gun for back then. I tried to solder the cable into the chip. Then I tried to flash it. And then with all the configurations on the proper partitions, then I managed to flash the entire image with the modification that I need, and I got the firmware running. So that brings me to another thing, because due to some sort of laziness, I always think that if I choose not to flash the firmware into the chip, is there any way for me to test? That was like 3-4 years ago, 4-5 years ago. I couldn't remember. Most probably 4-5 years ago. So my idea was, can I use QEMU to boot up the firmware to make sure that the firmware that I try to put it together, the new firmware that I modified, that I try to put it together, able to run inside QEMU. There is some very there's not a lot of information on Google on how to run this firmware. I tried to put everything together, and then after few days of research, I managed to put up my firmware, and that leads me to another way of research. So if I can boot up my Xiaomi firmware from QEMU, does it mean I can do more things with this particular firmware or this particular method? So after I save my Xiaomi, patch the firmware, and then to patch the location checking check, and then I able to use it. So I flash everything back. Then I continue with my second project. So the logic is very simple. You get the firmware from internet either, or you extract from the chip, or you try to sniff it from the whatever places that your device try to download the firmware, or you just go to the official website and try to download the firmware. Okay, so technically what I did with my cam is I download the firmware, I patch with the patch that I need, I put in a telnet that is some sort of backdoor. Okay, I flash, and then I can control the camera remotely right now. So if I'm able to do this, okay, can I do more things with the firmware? Okay, now I know I can emulate it. So can I have RCE, or can I fast the firmware? That is what I was thinking back then. So by looking at the firmware, then I tested a few more firmwares, but I discovered there are a few things that I can do if I don't use a QEMU. I can use a MIPS development board, or I can use Raspberry Pi for ARM or Arch64. The only issue with a Raspberry Pi is you always have this libc issue. Raspberry tend to use a different version of libc and this different version kind of boot up. So sometimes when there's a libc conflict, you will not be able to use the libc that you prefer, and you're going to stuck with Raspberry Pi's libc. Okay, so these are the few issues that I always face. Okay, and there are one possible issue, which is the assembly instructions for ARM64, especially, or for ARM. You have all the different versions, so the older hardware might not be able to run the newer firmware or the newer binary. So these are the few things that I face. So then I was thinking maybe emulation will be a better way, using a QEMU to emulate the firmware and try to run it. So the logic that I have during that time, it's if I use QEMU and try to run a firmware, I will have more space for sure, because I can define my own QCOW format and the size of the QCOW. That is number one. Number two, it's I can increase the RAM to more RAMs that I want, so I can run few more programs. Okay, and then if they are running on a single core, I might be able to do multi-core slightly faster compared to what they have originally. Of course, the limitation is still in the architecture, but it's more flexible for me to do what I want. Okay, so together with the vanilla Debian or vanilla whatever distro that based on that particular architecture. So if I want to emulate a ARM firmware, I need to install a vanilla version of ARM Debian into my QEMU. Then I will copy in the firmware and I try to execute it. Okay, that is my original plan. And then of course, the best advantage is I have GCC, I have GDB, I even have apt-get in the entire OS. So it's very, very convenient for me to do whatever settings or whatever changes I want to the firmware. So in order to run the firmware, we know that for sure, we know that there's only, most of the time, okay, 99% of the time, there's only one binary you need to interact with, which is the HTTPD. Sometimes they call it light HTTPD, sometimes they call it HTTPD, but it's the HTTPD server that runs all these things, the interface, the firmware, the controls, and inside there could be some little CGI, and it's most of the time the HTTPD will be calling the CGI to do the whatever stuff. So the logic is very simple. If you have the firmware, try to look for the OS is running on is based on which binary. Take that binary out, try to run it, and that's it. That's all you need. So these are the boot up script to run all the different version of Debian. So for MIPS, you have a different way to boot it up. For ARM, you have a different way of boot it up. Don't copy this and don't screenshot this. This method is all outdated. I'm just sharing with you the pain that I gone through, and why do I need to design and to have a Qiling framework. So the easy way out, it's like what I mentioned just now. You install QEMU, you install a vanilla version of Debian based on that architecture. So again, if I want to emulate the ARM firmware, I install QEMU, and then I install ARM version of vanilla Debian. Then I copy in the firmware, I chroot, and that's it. That's all you need. But the issue is sometimes if you want to GDB a file, you will not be able to do it due to the chroot don't have the proper library that you need. Okay, so easy way out is chroot, but if you want to do more things, chroot is not the right method. Chroot is not the right method. Okay, so then we try to run it inside the virtual environment. Okay, so issue number one that we used to face is file not found. So the LD, the load library file, it's not there as long as you place it properly, and then the file not found issue will go away. And then you need to fulfill in all the .so or the system library into the right folder, so your binary able to do it. So you can actually copy, or you can actually try to soft link it. If you have more issue, they might be if you get a seg fault without a clear error, you can use strace to find out the issue. So most of the time, it's there are some folder missing. They try to write into some folder and some folder missing, or they try to write into some file and some files are missing. So you can just simply touch. Okay. And these are the issues that actually are interesting. You know, when we started this project, we spoke to a few persons like sound memos and all these people. NVRAM, it's the thing that we always wanted to conquer. It's how we want to do it. Different people got different idea. So we were thinking that, you know, we find the source of the NVRAM, what kind of data we feed into the binary, and everything should work. So we have seen firmware with UDS, Unix Domain Socket. So later I will show it to you how you can emulate your Unix domain socket. And then there are some binary they just read from an INI file. When the system initiate, they will dump from the NVRAM, and then they save as an INI file. So these are the few ways to kind of skip the NVRAM check. Okay. And then, of course, sometimes by writing a small little program, you will be able to skip the NVRAM check, but that is not the main topic for today. So, of course, like what I mentioned just now, a fake NVRAM will always help you to solve your issue. And then one of the common error that we get is the BR0 interface. So that is rather simple. Create a bridge interface with your ETH0 and ETH0. So then you get your BR0 interface, and your HTTPD binary able to run perfectly. Wireless device, sometimes you need to get that WLAN0 interface. So you can be as easy as rename your ETH0 to WLAN0. Then your firmware will not control. So this is the way that we try to run a binary that we extract out from the firmware and try to run a vanilla version of a Debian for that particular architecture that you want to emulate. So if everything else fail, found not found, you try to fix it. You know, you try to fix the interface issue. You try to fix everything, and the binary, the firmware binary inside your vanilla Debian is not working. Your last resort is to patch the binary. Okay, most of the time, it will work. Sometimes they check for, let's say, /dev/cam, and you got no idea how to start the thing, and you try to patch it, and it will still work, but it's still sometimes not most of the time, but sometimes it will not work according to what you like and how you wish it to be. So after all these problems that we face, from messing with the hardware, messing with a QEMU, we were like, or at least me, I was thinking, can I have any tools, or can I make a tools that will actually runs the firmware on a very native way of emulation. So that is my dream during back then. Okay, so we have seen this. Okay, of course, by using QEMU plus vanilla version of our Debian will give us a few advantages. Number one is we're going to have multi-core processor. We discussed this before. We're going to have more RAM. So if the original firmware, they only have like the original hardware, they only have 1 meg, 2 meg, 4 meg, 8 meg of RAM. If you need more, like 256, 512, or even 1 gig, all right, then a vanilla version of Debian plus QEMU will be able to give you that kind of capability. But can we move one step forward from this emulation thingy? So my idea is, can we just make use of whatever processing power? Okay, that's number one. Whatever processing power, RAM, okay, with the hard disk space or whatever. So additional processing power, RAM, and hard disk space from our x86 platform, which is our home PC server or whatever. Can we make use of that resources and try to run all this firmware? And we can do all kind of analysis with it. So that is what we wanted to achieve for Qiling during the idea and design stage. So what is required is we need a debugger, we need a disassembler, or we need both. That is what I have in mind. And we should be, since we are emulating IoT devices, that means we should be able to run Linux. Then why not we just run BSD, Mac OS, and Windows? Just emulate all the OS that are commonly available in the industry. Okay. So, and we should be able to support MIPS, ARM64, and x86. That is what we want. Okay. Of course, x86 is always a must. So, okay. Of course, the first thing first is people as lazy as us. We were thinking, can we just use QEMU and try to modify it? I mean, we were using QEMU before, so can we use QEMU in our new project? So the answer is no. I mean, we cannot rely on VirtualBox. We cannot rely on QEMU. We cannot rely on Xen. The only reason is they are emulating too many things. They are emulating the device driver that we don't need. They are emulating the keyboards, the mouse, the sound card, the display card. You know. So once they are over emulating, then we will have more limitation, and we're gonna have more issues on the instrumentation. So we decided to go on with QE. We decided to go on with Unicorn. Unicorn, it's a stripped down version of QEMU. It only emulates a CPU, and then these are the CPU that we need exactly. We need ARM, we need ARM64, we need MIPS, we need x86, 32-bit and 64-bit. That is what we need exactly. Okay, and then it can run in different platforms. That is what we want, because we wanted to emulate FreeBSD, Mac, Windows, and Linux at least. And we want this framework. We want a Qiling framework to run on top of Unix, base OS, Windows, Mac, or FreeBSD, whatever. Okay, so the only limitation, okay, or the only thing Unicorn emulator they don't have it is it can only emulate CPU instructions. It cannot go more than that. So this is the best scenario. Qiling is going to build something on top of Unicorn engine that can run an actual file. So that is, we got a clear target, and this is what we wanted to achieve. So this is a Qiling framework. The entire idea is very simple. It's going to be cross-platform. It can run on Windows, it can run on Mac, it can run on Linux, it can run on BSD, and it can emulate Windows, Mac, Linux, and BSD. Of course, it can emulate x86, ARM64, and MIPS, and it can run on top of x86, ARM64, and MIPS. Android is not here because I categorize Android in Linux. Okay. So it supports read-in of multiple file format, PE, MacO, ELF, and right now UEFI. We can run, we can fast, we can analyze UEFI, which is your BIOS. So we'll emulate. Everything will be run in a sandbox environment, and we have a rich set of API. The API doesn't come in a day, or doesn't design in a day. When we use more Qiling, and then when the community started to use Qiling, people started to contribute more codes, and that is how we have idea on, you know, hey, we should add a bit more API to do this, to do that. So for example, I will give you some example right now, a bit later. Everything is on Python. Don't try to argue with me why not Golang or Rust or whatever. This is not part of the discussion today. And of course, we support GDB, IDA, R2 support, and we can do OS profiling. Okay, OS profiling is fun in Qiling. So what does OS profiling do is, if you try to analyze a malware today, and the malware only recognize certain version of keyboard. So let's say a Chinese keyboard. If they look for a Chinese keyboard, only they try to infect the system and go a bit further. You can always use OS profiling to profile your Windows sandbox and to have a Chinese version keyboard. Then you will allow the malware to run further from there. That is part of the OS profiling. Of course, what else? The API. So we can do all different kind of API. So let's say you want to do you want to hook basically every instructions. Yes, you can do that. You can hook on the IP address, every address, and try to insert your code. Yes, you'll be able to do that. You want to replace the entire syscall. So you try to run let's say a D-Link HTTPD, and then the HTTPD call like certain syscall that you want to replace it with your own syscall to make your analyze easier. Then you will be able to replace the syscall, or you can hijack the syscall to look at what kind of data they pass in. That is like your FIDA, your on enter and your on exit. Okay, or when there is a function that you want to replace. So the traditional method, okay, I can say it's traditional right now, or the current method, what people have been doing with if you want to replace a function, you're going to do LD preload, right? So we got a cleaner implementation on a LD preload. I'm going to show it to you later. So the next questions that we always receive is, so what is Qiling and compared to whatever things that, whatever emulator you have outside? Okay, so what are the differences? Of course, a QEMU user mode is one of the de facto standards that people use to analyze IoT firmware, but it's just a tools. You cannot do instrumentation, which means if the binary doesn't run, it doesn't run. You cannot do anything more than that. And it's not a cross-platform thing. So if you are analyzing a Linux binary using user mode QEMU, you need to run user mode QEMU inside a Linux to analyze a Linux binary. So you cannot run QEMU user mode inside Mac to run a Linux binary. So it same goes to a usercon. Usercon is a framework. It's not the tools. It is like a QEMU user mode, but they are also doing a syscall forwarding, which they need to have that specific OS to emulate the OS. Okay, and then it only support Linux-based system. We saw Beanie last year. Okay, it's a Windows emulator, and it only runs a binary. So there is no difference compared to Wind. If I need to run a Windows binary inside Linux, I either use a Beanie or Wine. I mean, Wine you got more support, of course. And then the only differences between Beanie and Wine is there's no it's not a jail environment. It's not a isolated environment. And then WS, sometimes they compare with a WSL2. I mean, we know that that's from Microsoft and they are good, but it only emulates, and it's not a sandbox environment, and there's no instrumentation. Like Wine, you don't have instrumentation. Beanie, you don't have instrumentation. QEMU user mode, you don't have instrumentation. And early this year, we saw this project called Zelos. All right, it's a framework. They have instrumentation, but currently they only support Linux. And then I think the support of the syscall, it's not as complete as many as us. I mean, we are not complete, but we got rather more syscall compared to all the emulator outside. So how Qiling works is very simple. You put in your UEFI binary, your ELF, your PE, or your PE32 plus, or your Blacko, and then you try to set up the environment. So do you want to do a syscall hijacking? Do you want to do a libc hijacking? And then you set up all the environment, then it will run. The instrumentation engine will start. Then you get the end result. Okay, so this is how you should be looking at. So when during the entire Qiling, one of the very first obstacle that we face is the loader. So we know that for sure the loader is not the loader is not a parser, parser is not a loader. Of course, by doing proper job on the parser, you will get. I got a question, but hold on. All right. By doing the proper job on the parser, you might or might not get the loader. So what we did is we just try to finish everything. We just try to fix whatever things that we have, okay, and then we rewrite the loader for PE, for Mac-O and ELF, so we can read the file, we can lay out the memory properly, and then we can make this thing run inside Unicorn engine, which we only have the CPU. Okay, and then all the syscall. So we try to write as many syscall as possible, just like Windows API. We try to write as many as possible. Then for all the syscall, we can actually if you don't want to use our syscall, you want to define your own syscall, we do have an API to do that, or you want to execute partial syscall and you want to add more. So that it is all possible to do that. So you can always design you run your binary, you run the syscall that you have with us, which the standard syscall, and then you want to add more on the syscall. So everything is possible. All right, and then how we set up the CPU. So we need to provide as many CPU information into Unicorn engine, and then the Unicorn engine knows that it's not a pure Arch architecture based binary. It's actually it need to turn itself into an OS environment. So that's how we can we can initialize the engine properly. And then we also discovered inside ARM and ARM64 you need to enable the TLS and VFP. So these are some of the issues that we face and we fix. Okay, so the the one that causes a lot of time. I remember it was a couple of weeks last year. We tried to run a hello world, Unix, the Linux compile hello world, ELF, and then we stuck somewhere, and then it took us like 3 weeks to find out Unicorn doesn't support this particular memory, this CP0C3 ULRI configuration. So it ended up we need to write a pull request and send it to Queen, and Queen need to put into the entire project and have a proper versions to work with Qiling. So these are some of the obstacles we face. Okay, so a very short introduction on what you can do with Qiling. So number one, it's you can run any binary. You can run any ELF binary. Okay, you don't have to. You just need to define the binary, and then which root FS. So this root FS will what is inside this root FS is, if you look at our example folder, that is where they contain all the SO, your LD files, your let's say your libc or whatsoever. So that is where you keep all your root FS. So the format is exactly like your root, your slash usr slash lib slash usr lib slash usr bin. So that kind of folder architecture. So the one cool thing over here is we have this hook, which means every instructions that they execute, it will invoke this print ASM functions. So this print ASM function simply means every instructions that we receive, we will disassemble it and to print out the disassembly. So when you try to execute this entire binary, this hello world binary, it will invoke the print assembly, so you can look at each and every disassembler of the binary that you execute to know what is happening and how it has been running and what is the issue and so on and so forth. All right, so this is example number one. Example number two, it's you can run your exe within Qiling and try to invoke in a debugger. Okay, so the example that we have right here, it's we are running a Mac-O exe inside Linux. Sorry, it was Windows. So we try to run a Mac OS binary inside Windows, and then inside Windows together with Qiling. So Windows install Qiling and turn on the Mac O, and then we are using a Windows version of IDEA Pro to connect to Qiling to get the debugger output. So we can use Linux to debug exe without Windows. We can use Linux to run exe and use R2 to debug it, to use a GTB to debug it, or even IDEA Pro to debug it. One thing I never put it here, it's we can even debug shellcode. So you can run and execute shellcode. You can run and execute shellcode within this Qiling and attach to a GDB. So you can do your GNU debugger or your IDEA Pro or your R2. So these are the few things that you can do. Of course, this is what everybody comes for today. Thanks to Dominic, we're able to run Fuzzer. So when we design the Qiling, we wanted to have a platform, okay, and then every tool should be able to use for cross-platform. So the debugger you can use for cross-platform. So same debugger, you can debug exe, you can debug Mac O, you can debug ELF, you can debug UEFI. So these are the things that you can as long as we support that few platforms, you can debug the few platforms. As long as we support the architecture, you can debug the few architecture. So same goes to the Fuzzer. So if you want to use the Fuzzer, if you want to use Qiling to run a Mac O binary, then you should be able to use the same Fuzzer to fuzz the Mac O binary. We can even since I said that Qiling can run UEFI binary, we can do UEFI emulation. You can use the same Fuzzer to fuzz UEFI emulation. And for IoT, we have ARM, we have MIPS, we have ARM64, the three most common platform. Then of course you can use the same Fuzzer to fuzz these three architecture, and of course it's running on Linux. So that is the beauty of Qiling. We don't do a symbolic execution stuff. No, we don't do that. To answer your questions. Okay. Of course, the entire idea was it always started with a firmware analysis on Qiling. So like what I mentioned just now, I'm able to run quite a fair bit of binary inside QEMU. So can we have more instrumentation, or can we do a better NVRAM emulations when it comes to a firmware emulation? So firmware analysis is what we are going to look at today. So these are some of the demo. These are some of the demo code. So to run a binary, as simple as you put in your file, you define your file, you define your rootfs, and then which the OS type, yes or no, up to you, and which debug mode, then you'll be able to run. We can even make a brute force crack me challenge. So this crack me is from one of the Korean CTF website. So we write a very quick code to run the crack me. So the flag is rather simple, and then we just run through all the options that we have, and to print out the flag. Okay, so we are pretty much on time, and we are still on time. So before I go into all the hands-on, do you guys have any questions? Do you want me to answer? Then we still can go back to the slides that you have questions. Am I disconnected? No, I'm not disconnected. Okay. What do you mean by overhead forces core handling? Additional syscall, yes. There are like 500 plus syscall in Linux, and then there's no way for only us to complete all the syscall implementation. And we hope the community can help. This is an open source project, so, and we are not making any money. So any help is appreciated for you guys to contribute into the syscall, and we are finding some better ways to make the syscall easier to implement. As in, can we? One of the option is we should have an option to forward the syscall to Linux, and let Linux handle the syscall implementation. That is option number one. Or we gonna modify Linux kernel to make it into a library and let Qiling loads it, so we will have the complete syscall list. That is option number two. We are still looking at the option, and we still got no idea which one is the better method, and how we can fix this thing. So before we start, do you guys have Linux installed on your PC right now? No. If you're looking at a QEMU always rely on your x86 syscall, and to perform the syscall. So you will not break the you will not break the multi-platform. Syscall forwarding will not break the multi-platform. Does P32 loader initialize all data structures in the TB and PB? Yes, we do. We do have that. So if you check the code, we do have that. I still don't have any idea. The only possible way to fix this is to strip Linux kernel to turn into a .so, maybe a thing called kernel.so, and then and load it. That is the best way that we can imagine. Yes, somebody's typing, so you guys turn on the mic. Cool. Can I know whose mic is on so I can talk to him? Anthony, are you typing? Anthony, can you talk?
Yes.
Oh, cool. All right.
Yes. I'm installed.
At least I'm talking to someone. Shit. I'm talking to the wall.
No. Here. I'm here.
Okay,
here.
so okay. What I'm going to do now is I need a Ubuntu or WSL2, not WSL1, WSL2. It's either Ubuntu 18.04 or 20.04, up to you. And of course your WSL2 it can be Ubuntu or whatever thing you choose. Not specifically Ubuntu. It can be Kali Linux or whatever. The reason why is we streamline the configuration so everybody will not have any weird issue, and don't make me look like a technical support. You know what I mean? Okay. Run this command. The easier things is don't do pip3 install Qiling. That will complicate the class. So just do git clone the code from the repo. So that is easier for us to sync. I will copy this and paste it here. This is a rather long command, so the shorter one is fine. So make sure you guys have the apt-get and then leave the AFL part. We will go into the AFL part later. So I'm going to give you guys 5-10 minutes to get yourself prepared. So this is the download link. Download this link and extract it inside your Qiling's folder. So you already do your git clone, and then you're gonna like you did your git clone here. Okay, then what you're gonna do is here, then you're gonna get your file. Once you get your file, then you're gonna untar it. You're gonna untar the file, then you'll get your folder over here. You guys know what I mean. What are these things? Go faster. Okay, go slower. Do you guys manage to download the file from Google Drive? Okay, cool. Okay, I'm gonna wait for you. Don't worry. We have like all the time in the world right now. We have 1 hour. Anybody else not chat? Anybody else wants me to wait? I saw done. Anybody wants me to wait? Tell me. I assume no. Yes, you're right. I'm gonna wait for you, don't worry. And so once you're in the HITB lockdown 002 directory, that is where you should put your AFL++ folder over there. So follow the command to install AFL++. Your that's where you clone, you make, and then you build Unicorn support. It will take some time. Yep, inside the folder, you're right. Inside Qiling HITB 2020-02. It's not inside Qiling folder, it's inside the HITV folder. Never mind, take your time. We got 3 firmware in there, so and then we have like 45 minutes more for us to play with. You're gonna have enough time, don't worry. Yeah, the one that you grab from Google Drive. Yes. Yeah, the make is gonna take some time. Unless you're lucky enough to have some really strong CPU. Oh, that was fast. Is that the way that showing us you got a strong CPU? Or is that a way to show us that you are rich and you got a very fast CPU? Oh, nice. Can I show this? Like this one? Okay. Damn it. Who else is not done? Anybody have any questions until now for the AFL plus plus installation? And besides I am here, who else is from Malaysia? No. Anybody from my hometown? My beloved home country? Nobody from silly Malaysia? Anybody from China? Just let me know if you're from China so I will not start any communist story. Communist horror story. Okay, who is not done? Do I still need to wait? Let me know. Cool. Yeah, go faster. There you go. Okay. We're gonna start with this. All right. So we're gonna start the fuzzing first. Then you have a separate Windows for your fuzzing. That's what I'm separate terminal for your fuzzing. So we can leave the fuzzing to run a bit longer. What I did wrong yesterday was I let the fuzzing run at the end of the class. So I shouldn't be doing that. So first thing first is oopsie. What did I miss? Go to this website. So that there is a Metasploit code over here. This is the bug that we are. This is the bug that we are trying to simulate, and we try to fuzz. Okay, so the logic over here is very simple. We find some bug. We find some bug that we find some 1 day bug or whatever known bug to start with. So at least we know that the first confirmation we know that the fuzzer is working, Qiling is working. Then we know there's a working bug, and then you try to fuzz from there, and then you move on. So in this case, we know that the password field was it the password field? The UID field. The UID field is having issue, and then so just for example, it might be the URI field is having example the encode parameters or whatever inside the cookies, it's having issue. That is where you can start to fuzz some other variables or some other inputs that you think that gonna that you after you fuzz you're gonna discover more bugs. But to start with, always, if you never fuzz before and you're not too sure whether your fuzzer is working, look for the bug that already exists. then you're going to fast from there, and just to make sure that everything works fine. So based on this bug and this firmware, so this bug is actually runs on DIR 815 firmware. So I think it was like DIR 815 somewhere. So what we do is so this is a DIR 815 firmware. So there's two parts of the file. Number one, it's the Python file. Number two, it's the sh. So we start with the easy one, the sh. It's just a one-liner to configure your AFL. Where's your path, and then your AFL fuzzer, then your path to your firmware. All right. So this is your firmware. So there are a few parts over here that you want to look at. Number one, it's before we execute, we put in the environment. So the environment variables, the environment variable simply says is this a post, and then what is the username and password. So the issue over here is the password. Okay. So if we move down a little bit, then what you can see over here is this is where we put in the AFL code. So we redefine the cookies, and then we put in whatever input from the AFL code. From here, AFL gives us the input. We put in the input, then then we do the execution. Okay. So this is the independent function. So how to run? We run the headwig.cgi, which described in somewhere here. Where was it? No, the headwig CGI. So it's exactly the same bug. We are using the same bug and try to simulate inside the fuzzer. So during the first execution, we will execute the headwig.cgi file, which is here, together with the folder. So if you can see, so DIR 815, it's the home folder. So what is inside DIR 815? That is, sorry, the so you can see inside DIR 815, which is equivalent to this one. This is all the system folder that we have. So that's why I call it rootfs in the previous screen. So this is how we use one of the API, ql.man.search. So it will search through the entire memory to look for these particular strings. So once we manage to locate this particular string, it will return with an address. So the address that it discovered, that will be the address of the target directory. So what we're gonna do inside here, we will write the environment, the new environment variables inside the target variables, and then we continue execute the headwig.cgi. So this is what the fuzzer does. All right. So let me repeat it again. How this script being executed is, we set up the environment, then we let Qiling knows that these are the file that we want to run. So during the execution, the initial stage of the execution, it will look for this line inside the entire memory, and then it will generate the input. Then you will rewrite the input and continue run the file and see whether it crashed or not. So just as simple as that. Until this stage, anybody have any questions on how the execution works? Any questions? I assume no. Okay, cool. So if you try to run the you cannot run the Python. The Python is just for you to do the testing. What you need to do is so like what I said just now, you should run in a separate screen. I think there's some rubbish left over. So this is how the fuzzer runs. Everybody managed to run the fuzzer? The shell script. Your AFL++ should be 2 folder back. Did you put your AFL++ directory in the right place? It's not in Qiling folder. It should be in this folder. Your AFL++ should be in your HITB 2020-002 folder. Okay, cool. So everybody see the fuzzer screen? Anybody else have any questions? If you cannot run it somehow, or you might think this Chinese man is a liar, try to cheat your 2 hours. Okay, cool. Roland, any issue? What is the exact issue that you are facing? This Chinese man cannot speak proper English. No. Only two. Only it's inside your HITB, not it's inside your HITB folder, not Qiling's folder. Oh, that is fine. Just do that. That is the AFL issue, not my issue. You need a sudo though. Nicholas, it's inside the HITB folder. Your AFL++ should be inside the HITB folder and not the Qiling's folder. So only 2 folder down. So if you're inside your DRR 815 folder, it's only 2 folder down to see the AFL++. Look at my screen, only 2 folder down, not 3. 3 is wrong. I mean, it can be 3. You need to change your shell script to be 3. Look at that, the shell script only 2. 2 and 2. Then, I don't know, you update the shell script, that should be fine. Or I fucked up the shell script. Most probably. If you get a timeout, error, do this. This is your timeout error. Well, what do you mean by the shell script in AFL? The shell script is inside dir 815, not the AFL common template. I'm not too sure when is the video going to be available. The organizer should be able to give you a better answer. It is recorded. It is. It says recording to the cloud or something. Let me see. Recording to the cloud. Like cloud is in somewhere. To the TikTok server. I don't understand what is crash with a pipe at the beginning of call patterns. If you have a call pattern, you need to run the command that with sudo. If you have issue, try to reinstall the AFL. Where the hell is my AFL? You might not install the AFL properly, so you might need to. The easiest thing is try to delete everything and try to run the AFL again. That will solve your issue. PE file. Giovanni. I hope I get your name right. You can actually run the file with you can actually do this to do this will not test the AFL, but rather to test the Python script is correct or not. The PA file is not part of Qiling. The PA file is part of, if you install Qiling through PIP, then you will get the PA file, but we are not doing that right now because of the field dependency. So yes, I might forgotten that part. So do we solve all the call pattern issue? Fork server timeout is you can try this. No module named Unicorn AFL. That means you didn't install the built-in Unicorn support. You installed it wrongly. Don't worry, you can do a few more tries. It took me some time to understand the whole damn thing, so don't worry. Anybody have any issue? So Roland, your issue could be you are running the different version of Python. Then you might have that issue. Because the Unicorn AFL is actually the Python binding that will bind to different version of your code. So you might have issue with that. Yep, capstone and PE file. I totally forgotten about that. So the easiest way it's by running this command will solve your PE file, your capstone, your keystone, or whatever stone issue. Then you will run the code from the Git repo. Then that will be okay. Everybody got their fuzzing screen? Anybody else need help? For free? The fuzzer will complete when you stop it. The fix for Fox server timeout is to delete the output folder. To delete everything inside the output folder. Okay, so that is the next thing that I want to talk about. So you can see the execution speed is a little bit slow, 70, 80, sometimes 100 execution per second. So there are a few ways to increase it. So that will be your homework for you to do your research. So method number one, okay, the method number one is, of course, you can use AFL to fork into different instance, and you can run different instance for them for you to have a few more instance. So you can see the CPU utilization is rather low on the emulation plus AFL. So if you run few more instance, then you have a combination of a few more executions within seconds. All right, so that is how you increase the speed. Method number one. Okay, so method number two, that is your actual homework. Method number two, it's of course I will not check your homework because I got no chance to check the homework. Method number two, it's so if you look at this file, inside Qiling test, okay, inside Qiling test, I got a test ELF. So you're going to look for partial. So this is just to give you an idea on how you can execute a binary faster. So what I did with this file is very simple, okay? So inside your Qiling folder, you have all the files that that I'm going to show you over here. So there is a sleep hello. There is a sleep hello, and we are running the sleep hello over here. So you can see inside the source code of sleep hello.c, the binary actually sleeps for 1 hour before it prints a hello world. Can you see the source code? Can everybody see the source code over here? Okay, so what we are trying to do in this test partial Linux is, in this code, is we try to stop at this address. So where are these address? Okay, this address simply means so you can see 1094. So right before the sleep, okay, we do a hook, and the hook move to dump. Inside the dump, we dump out the current memory and we dump out the CPU context. CPU context simply means the CPU state, what is the current state of the CPU and all the register you have inside the CPU, and then the memory state. So once we save this thing, this will be more or less equivalent to your VM snapshot. So we have a snapshot of the memory, we have the snapshot of the register, and the CPU context. Okay, then we stop the emulation. So everything will be saved right over here. And we run the file again. So once we run the file, we're gonna do the we're gonna ask Qiling to restore the memory, to restore the CPU context. So you have the previous executed register, the previous executed memory. Then what you're gonna do is, during the execution, you're gonna start 109E. So start 109E after the sleep. Okay, then you continue the execution until finish. All right, so that's the idea. So you know that. So if you know a certain binary, you only need to fast from here to here. You don't have to execute the entire memory because the loading will be slow. Everything will be slow. So if you're able to spot, so in this particular case, in this particular fuzzing case, you're able to spot where you want to fast and where you want it to stop, and then where you want to write in the memory. What you can do is, you can do the same thing, run it one time to save the context of the to save the context for the partial. The fast iteration is fast iteration. This is to control the binary. So we know that we only need to execute maybe 1% of the binary. Then we just need to execute 1% of the binary and fast that 1% of the binary. So you have a slower starting, you have a faster starting time, you have the faster execution time. You don't need to process all the unwanted stuff that you want. Then you can reduce everything. Then you only execute and fast that particular part. So that is your homework number 1. And to be honest, that is how you can make a proper fuzzer. A proper fuzzer should be done that way. You don't execute and fast the things that you don't want to execute, because it's going to be wasting your CPU resources. It's going to be like wasting everything. So that is so like what I mentioned just now. One is you have multiple instances of AFL, or you do partial execution plus multiple instance, then you're going to have a lot of you have stronger resources to run it. Okay. How much time do we have, David? Okay, so number 2, it's Tenda. So again, Tenda. So can you see here? The Tenda HITB 2020, Tenda AC18. Everybody got this folder? All right, so if you open up the Tenda Python script, you can easily see that there is an NVRAM emulator over here. So the HTTPD of Tenda is actually listening from the CFM socket. Okay, this CFM is not that CFM you know. So the CFM socket will actually provide the information. So when this HTTPD connects to the CFN socket and then they ask for information, the CFN socket based on the request and return the data, then that is how we keep the HTTPD running. Okay, so few important things over here. Number 1, it's the script. So in order for you to run the Tenda, so run it this way. So as long as you see a HTTP request, you have it over here. Shoot out your browser. Go to localhost port 8080 and you get your Tenda browser interface. Everybody have that? Okay, cool. So number 1, it's irregardless of what kind of interface they buy, Qiling will always bind to localhost. There is an option for you to change that. So if you want to change that, then go to the documents, read it on how we do it, and then we always buy on additional 8,000 ports. So if buy on port 23, we're going to add 8,000 in front to make it 8,023. So this one originally was a port 80. That's the reason why we bind to a port 8080. Like what you know, if you need to bind to port 80, you need a privileged user like root. So we are not root right now. So that is the reason why automatically we add in a port 8000. So of course you can place the firmware. All right. And this firmware it's rather famous. There are a lot of IoT courses uses this firmware to look for bug. Okay, for mainly 2 reasons. 1, there is a lot of bugs in this firmware, and they are not fixing it. So if you go to the website to download the latest version, you will still have the same bug. So it's a very good training firmware. I think the vendor want to make it that way. I'm joking, by the way. So. And number 2, it's I better delete this before I forget. So you can see this overflow code. Do you guys have this overflow.sh? So if you run Tenda in your Python on this window, and then you have your overflow.sh, It shut down, but it didn't crash. But let's do it again. So overflow.sh, then it will kill the entire process. Okay. So why I want to show you this is, you know that they send in, you know that once HTTPD connects to a main.html, they will check for cookies, password equals to something, and if the password is too long, there is a crash. So it's very clear we have a buffer overflow situations over here, right? So you know you already know there's a confirmed bug, and then you already got a firmware which is vulnerable. So this is your homework number 2, to build a fuzzer for these things. Okay, this will be a little bit harder compared to the D-Link, and then yeah, you should take this as your research work. You can see this is an overflow, so because we already written R0 and R3, so what you need to do right now is find the proper length. Okay, make sure the thing is being overflowed, and see whether you can overwrite the PC or not. Then from there you can put in your AFL code, copy from DIR, do your modifications, and then find where's the executions length. Then to build your fuzzer to fast Panda. That is your homework number 2. Okay. Understand? Number 3 is Netgear. So Netgear, I don't give you a lot of options over here, but what I do give you is if you check on exploit.txt, and then this node is rather new. Okay, somebody posted bunch of Netgear's exploit. He collected quite a fair bit of Netgear exploit. So based on this URL, what you can do is look for the firmware and redo the code. So you have your tools, you have your exploit. So look for the firmware and try to resimulate the code. Then that is how you can fast your Netgear. But what I wanted to show you is this. So one of the function that we put into Qiling, it's you know that inside IoT that there is a lot of times a lot of files is required being opened by the binary. So for example, inside Netgear, there's a binary called nvram. So it's inside user has been nvram. Okay, so this nvram always wants to open a file called tmp nvram, and this file cannot be faked. And this file sometimes it's you cannot just touch a file, it will crash. So what we did over here is we have this API called fs mapper, file system mapper. We map this file, which is inside rootfs. So rootfs slash rootfs slash tmp slash nvram. So whenever this binary try to read this file, we will forward to here. So this is a fake file. Okay, this is a fake file of this thing. So when there's a file operation towards tmp nvram, if there's a read, we're going to return this. If there's a write, we're going to return this. If there's an fstat, we're going to return this. If there's lseek or close, we're going to return whatever things is required. So if you are analyzing if you're fuzzing if you're studying a camp, a digital cameras, a firmware. So let's say they try to read DEV cam. So you can do the same thing to when they read DEV cam, what kind of data you want to return. When they write to the /DEV cam, what kind of data you want to return. What character device, what you're trying to say. This is all the file IO the file operations thingy, as long as there's a file. And then you can use a file mapper, the file system mapper, to map and return whatever data during read, write, close, fstat, or lseek. Any questions? We are almost done. We are the kernel, so we don't have a ASLR. Of course, we don't have SLR. We don't have all the mitigations because we never built in the mitigations. If you look at the syscall emulation code, a lot of things we just returned okay or we returned 0 into the system. So we don't really implement it because inside an emulation environment, you don't need all that. I mean, why the hell we need a ASLR? The only reason we need ASLR is we want to look at the binary, how they react inside ASLR, but we don't need it for now. That's why we don't have ASLR in there. So thanks to we don't have ASLR, that's the reason why you can restore the memory and to replay the memory. The slides, let me see, I should have the link to the slide. Okay, we got the slides. I don't do I'm not a big fan of vulnerability discovery, so my exploit writing skill is bad. To discover bug, it's not my hobby. My hobby is to build tools that you guys need, to build framework that you guys need to help you to I'm more into develop tools that help you to find bugs easier. That is what I like. What else? We have few more minutes, so we have 1 more minute. So let me finish these things. Okay. We got more features. We got more features that you can ever imagine inside Qiling. So always please go to docs.qiling.io. Go through all the APIs that we have. Okay, it might surprise you what kind of API we have to help you to do your fuzzing, your reverse engineering, or for you to study more on your binary. Most of it, a lot of it, like what I say, it's a community effort. Okay, like UFI written by this guy. The OS profiling written by Simon, and then we have UEFI. We have on enter, on exit. If you're familiar with Frida, you have this thing called on enter and on exit. RTOS ferment, no, not yet. We are looking at STM chipsets. We are looking at RTOS. So yeah, there are a few things on the roadmap. But yeah, you can contribute. Android binaries we can run. So yeah, there are few more. There are a lot more API that you can play with. And then I think one last thing, it's I'm not too sure whether you guys familiar with Unicorn engine or not. We are in the roadmap to build a Unicorn. Unicorn is version 1 since 2015, and 5 years we don't really update it. We update some minor stuff, and it's still based on QEMU 2.1.2. So now the thing is, we wanted to make it work with Unicorn 2 should be able to work with QEMU 5. So the core engine will be QEMU 5. So please go to Queen's GitHub. Okay, look at the issue and see anything you guys can help, or anything that you wanted to help. So like what I said, no, we cannot emulate APK, but we can emulate things inside APK. If we're gonna emulate APK, we're gonna emulate the goddamn entire Java, which I hate it. That is one hell of a language. Oh yeah, give Qiling a star, please. God damn it, I know who is that. So that guy that asked you to give a star, that is one of our key contributor. That guy wrote the GDB plugin for us. So, gentlemen, thank you very much. Thank you for your time. Good 2 hours. I hope you're not wasting your 2 hours over here. It's a Sunday. I think you have better things to do. 4 a.m. Damn it, 12 hours. Are you in oh, you must be in US or Canada or somewhere. Oh, James, are you belongs to Donald Trump? All right, gentlemen. You got the slides. Follow our Twitter. Follow Qiling's Twitter. So we'll post updates. We got more we got more video. So the only thing I want to add over here, it's one more thing before I keep on forgetting. After Black Cat presentations on Queen, we will release the kernel emulation module into Qiling. So you can emulate and debug rootkit for Windows, for Mac, for Linux, or you can emulate and debug system drivers. So Windows is .sys, Linux is .ko. Those are .ko file, or Mac is kernel extension file. So we can emulate and analyze all the files after Queen release the module into Qiling. That will be something in August. So we can do file and we can do kernel modules. All right. Thank you very much.